And along with my group members, Nathan Sandoval, Jonathan Sandoval, Laura Deve, Armando Martinez, and Perry Barrow, we'd like to introduce you to a revolutionary new vacuum called the Vakenstein.
I'd actually like to give you a brief demonstration about how our vacuum works. Side brushes, as you did see, rotated inwards, bringing debris out from the edges and corners for our frontal part where our suction ports are located. And we'd like to give a special thanks to Dr. Moling, Dr. Truman, and the FSAE team who helped us out. And now I'd like to bring the rest of our group up to answer any questions you may have.
When are we going to see the video?
Too short.
They just played it.
It was too short?
I didn't see any.
Okay. It's fast. Actually, I should have recorded it for longer.
The pivoting assembly is off to the left there.
Yeah, it's on its side. That's the only way we could get it to, so we could show it right on. Originally, it was just the side brush idea, but then when we went into our market research and our survey, suction was by far a #1 complaint by people, so it was an issue we had to address in order to meet all of the specifications needed by our customers.
So then we're redesigning the pump?
We redesigned, yeah, all of it. Suction system, agitator area, and added a side brush system.
Actually, the key for us in our suction redesign was taking out all of the loss factors, because in a lot of vacuums today, even though they're called uprights, they're really a canister vacuum because you have that whole hose that goes up and into it. So there's a lot of head loss in that. What we did is we took that out and made it directly into the blower motor. That helped tremendously. Also, we changed the way that the canister worked. We took out some elbows and corners and stuff to make things, just take as many head losses out as we could, just to improve the suction ability of the blower. So the blower was a factor, but then also the pipe system.
A typical Dyson has about air watts of 350, where ours has air watts of 530. So it has a tremendous more amount. Not only that, but the placement of our suction systems with the larger one and the two smaller ones is also different from anything else on this, out on the market right now.
Okay, and I picked up on that, but I guess my question is, okay, so we did an analysis that said it should be 530. Did we measure that? Did Dyson, is that what they say on their website, or we took their vacuum and we measured that somehow? I didn't see that we measured this necessarily, rather than just calculated this. Is this true or what?
Well, Dyson claims to have 350 air watts. We did that during our research. And then when we did our calculation, we couldn't just find a vacuum motor and just put it in. We had to justify through our hand analysis, through our equations, why we picked this motor. And so we kind of did the equations, then we picked the motor. So
In order to actually do the testing, we would have to hook up like a water bucket to the bottom of the vacuum, and it was somewhat difficult for us to do that, so we kind of had to rely off the data. And so no, we did not measure that.
And so these numbers that we do have, though, this is in the flow system itself.
Yes.
Correct.
So we're assuming if an M&M got into this somehow, then we would be able to pick it up.
it does.
Definitely. We
It
actually
does.
tested that.
It does.
We tested the M&M.
Yeah.
We didn't test that.
I think it might be still in the canister, actually, the M&Ms.
I know we didn't just open it and put
No,
it
it
in.
does. It
So
sucks it in.
we did test it to make sure, because our M&M was our target, and it did pick it up. And that's mostly because it gets around the beater bar, and mostly what happens is that they're belt driven. Ours are, it has a timing belt, so it's got teeth in it, so it will prevent that. But what happens when the hair gets tangled in the joint between the belt and the beater bar, it causes slippage, so it just gives that awful hair smell. It's burning, and it prevents it from turning properly, which stops
The suction.
debris from picking up.
Our pulleys and belts are actually separated from the beater itself. I mean, there's really no way for hair to get into that section. It's kind of locked out. So that helps prevent the hair issue. In addition to that, to the Consumer Reports thing, we did take a look at that. We read a lot of literature on the fact that Dyson, even though it claims to be wonderful, in their own literature, they say suction needs to be measured in air watts. That's the only true measurement of a vacuum suction power. And like, whoop-de-doo, we have 380. In reality, if you take like a Kirby, and you calculate the air watts for any Kirby you pick up from vacuum store, they have somewhere around 700, something like that. But again, that's usually a calculation of the motor itself, not including the pipe. So what we had to do is we had to incorporate that pipe in there. And that's the common misconception is people will claim the thing has a lot of suction. But in reality, what they're saying is the motor has a lot of, the blower has a lot of suction. They're not including all those losses and all the places and where you get clogs and things like that in what they're saying.
I think Consumer Reports just takes a bunch of dirt, throws it down on the carpet, and then they measure afterwards what's left.
Right.
So that measures everything.
And so Dyson actually has quite a few, complaints about it, just like you said, and we looked into that. And that's why we wanted to make sure our air watts were higher than theirs, in perspective.
It's a standard accordion filter. Filtration wasn't one of our main aspects or specifications. It was quite low, I think, on our customer requirements. So we just used a standard accordion type filter.
We actually accounted for the filtration in our analysis. When we did our fluids analysis, we read some literature that says that basically a filter needs to be replaced after about 2 inches of head loss. So what we did is when we did our fluids analysis, we said worst case scenario, filters at 2 inches of head loss, and we just accounted for that in our fluids analysis. In this picture, you can see where the filter is placed, which is actually in the same location as we have it placed in our prototype. And again, when we did our analysis, we did account for the filtration head loss issue, and based off of that literature that we did find.
It was the selection matrix.
Oh, the selection matrix, the reason why it was a 3 was because it wasn't very durable, so the agitator
Oh, the
brush.
selection matrix.
Yeah, the selection
Oh.
matrix. That was something different from the specifications, right?
Yeah.
And the reason it was given a 3 was because it didn't meet our specifications, so that one which is why it was given a 3.
Weighted at 3.
Yeah.
Yeah, that's the one.
Okay.
Yeah, that's the decision matrix, not because it wasn't important, but it wasn't one of the key features that was good in those alternative designs.
What we were pulling out from them.
Well, the problems as far as failure or cost?
Well, they actually have a. They're actually really nice because not only are they incredibly cheap things that we found, but they actually have a built-in clutch that limits the torque. So we figured out that if the only things that would cause motor failure is either dirt, which it's isolated from the dirt pathways, but also over-torquing, so the clutch helps prevent that.
Could you briefly explain a little bit more about how the actual side brushes work? Like, when the vacuum's on, are they on?
No, they're not on contact.
So there's a
activate
switch
separate?
actually on
There's a
top that
switch.
you
Yeah,
can
they use-
activate on
Okay,
your
so you
end.
activate it when you come into contact with the corner?
Yeah, whenever
Yes.
you hit
There's
the
a button
corner,
on the
you hit
top
the
there.
button, it activates your pull solenoid, which brings them out.